Good morning, everyone, and thank you for joining us this morning. My name's James Thomas. I'm the Precision Application Lead for Europe, Africa, and the Middle East at Syngenta, based in the UK. And today I'm going to talk about or give you a little look into the future and look at what precision application technology will be coming your way in the future and help us apply crop protection products in the future. So some really exciting and interesting technology to share with you today. I think the most important thing, though, is to start by setting the deal, setting the scene with you guys as to why precision application will become more important and what exactly precision application is. Because there's lots of different definitions. And I'm going to start by setting the scene around what's going to drive us towards precision application. And many of you will be aware there's something called the EU Green Deal that's been published by the European Union. And although we're outside of the European Union here in the UK, I strongly believe that we will still follow quite closely the regulations and guidance that come out of the EU. So I think this is probably quite relevant for us here in the UK as well. And part of that legislation, or part of that Green Deal, was the ambition to reduce by 50% the inputs of crop protection into growing crops across the European Union by 2030. And obviously that is incredibly challenging to certainly us as a business who makes and manufactures crop protection products, but it also is a massive challenge to you guys who still have weeds, pests and diseases to control to produce sustainably and economically viable crops, essentially, that are profitable. And so precision application will essentially help us deliver the products more effectively and achieve those 50% reductions in targets that the EU are going after. And there's four main areas when you look at how products are regulated and some of the challenges where precision application will help. So the first one is spray drift. And I'm sure if you've tuned in to this presentation or to this series of presentations through the week, you will have heard lots about spray drift. Off-target exposure to non-target crops, environmentally sensitive areas, watercourses, ditches, flowering margins is unacceptable and will drive a lot of the regulation around pesticide usage and what's available to you. There's then point source contamination. So this is things like when you fill and mix your sprayer, pouring the product into the sprayer again. We don't want point source contamination. It's where water gets contaminated. So this is another area where precision application techniques will be able to assist. And I'm sure all of you have heard about the Easy Connect closed transfer systems, which are, again, a very important technology to help us minimize point source contamination. There's then operator exposure. You know, we need to protect the operators that are using these products. And again, another technology that fits nicely is the closed transfer system, which has again been touched on earlier in this week. And then finally, there's residues. You know, the amount of active ingredient remaining in products when they actually hit the supermarket shelves, and we need to ensure that through good application that we're minimizing those residue levels. So precision application can help in all those areas, and I hope you'll see those as we go through this presentation today. I think the other thing to say is that, and I'm sure you're well aware of this as you walk your fields or you are cutting your fields this year through harvest, is that there's a huge variation in pests, weeds and diseases. And I've just pulled out 3 examples here that have been taken in the UK. I mean, firstly, we've got a wheat field there with patches of thistles in. If you then look at the photo below, that's a drone shot of black grass in a a wheat crop. Again, clearly see the patches quite visibly. And then finally, we've got an all too frequent sight, unfortunately, a very patchy established crop of oilseed rape, partly driven by weather conditions, but also driven by pesky cabbage stem flea beetle. So yeah, lots of variation in weeds, diseases and pests. And when we look at our current approach to applying crop protection products, it's quite nice to use this analogy of a cut to your arm. So if you imagine we've got our field, which is the human, and there's a cut to the arm, and the current approach is we essentially mummify the field. We wrap it in various active ingredients, but there may only be the problem in one part of the field. And so would it not be much better just to apply, as we do to humans, a sticking plaster or a plaster over the cut? And that's the essentially approach precision application is looking to take. It's applying the product only where it needs to go in the field to control the pest, weed, or disease. And I think the first thing to mention there, and again, you probably would have got or had lots of this spoken about this week. The first step towards precision application is all about getting the basics right. There's no point spending hundreds and thousands of pounds on big shiny pieces of equipment if you aren't using it in a simple or got it set up in the correct way. And there's 4 key areas that obviously we focused on for a number of years to bring you best practice and best recommendations. Those are nozzles, the equipment setup, water volumes, and then also adjuvant technology. If you can't get those 4 things right, you're gonna struggle with some of the precision application techniques I'm going to talk about, and those fundamentally are very, very important. And I cannot emphasize that to be precise doesn't require you to spend lots of money. Doing any of those 4 pieces will improve your preciseness and your ability to control your problem. But then when we talk about precision application in general, what are we referring to? So currently on the left-hand side of the screen, we've got broadcast applications. So we're applying this blanket to the field. And there's 4 specific areas that we view as being a more precise application. The first one is band spraying. Nothing new, really. The technology's been around for a long time. Lots of people are already practicing it. So yeah, first one. The next one is prescription application. Again, lots of people doing this for things like variable rate fertilizers and seeding. This is looking at doing it with crop protection products. The third one is prescription banded. So this is sort of, I guess, at drilling, at planting, is only applying product around where the seed is placed in the furrow. Again, some companies offering this kind of technology, some growers already doing this, maybe some of the sort of more veg specialized growers. And then finally, there's optical spot spraying, and perhaps what we might refer to as the holy grail of precision application. And this is actually in real time, looking at the field, using cameras and sensors to identify the problem, and then making the sprayer spray. So those are the 4 areas of precision application technology that we're going to see emerging in the market over the coming years. So what's Syngenta actually working on? What are we working on at a European or a Europe, Africa, Middle East level? We're exploring lots of different precision application technologies which not only solve grower problems but also hit regulatory targets, so that again we still have the ability to control weeds, diseases and pests in the field. And there's kind of 3 main areas. There's obviously weed control, and we've got a big area of focus in sunflower and corn. Big focus on grass weed control in cereals, obviously very, very important challenge to you guys here in the UK. And then we've got the pre-plant burn down, so the creation of stale seed beds. Is there an opportunity there? We're then looking at insect control, so again soil pests in corn, things like wireworm, corn rootworm, big challenges to corn growers on the continent. We've got sucking pest control in veg and open fields, and sucking pest control in orchard and grapes. And then finally, disease control, perhaps less of a priority because there's a lot of products available, and there's also a lot of exciting technology coming through in the form of biologicals. But again, some of the more specialist crops, orchard and grapes and open field veg, where there's certainly challenges around disease control. So that is what Syngenta is focusing on. Now, the first thing I want to start with when we start talking about this technology in a bit more detail is actually to start with a technology that lots of people are making a lot of noise about. There's a lot of excitement, and lots of people consider it a precision application technique. And that technology I'm talking about is drone application. So very topical. Lots of people talking about this. It was all over the cereals event and the sprays and sprays arena. And I just thought I'd bring you a Syngenta perspective on drone application. Now, the first thing to say is there's a huge drone fleet or drone application fleets in Asia. Massive amounts of drones are being sold in places like China, Vietnam, Indonesia. And this is generic primarily because it removes the operator from a dangerous environment. It takes an operator with a knapsack of product spraying in knee-deep rice fields, paddy fields. So again, very advantageous in that situation. It is also incredibly useful technology potentially in some very specialized areas such as vineyards that are grown on very steep mountainsides. So in Switzerland, for example, they do permit the use of drones, and there's people applying products via drones on these very steep vineyards where driving a tractor would essentially be taking your life in your own hands. And then also in the amenity sector, so for spraying things like buddleia, for example, an invasive species on railway cuttings, railway sidings, are very specific use cases where health and safety is obviously a major challenge, and drones remove the operator from that health and safety risk. However, unfortunately, under the Sustainable Use Directive, aerial application and drone application is considered to be a type of aerial application, is banned except for some very special derogations. For example, in Germany, there is the permitted use of a drone for a very special use case. And the reason that it's banned, or the reason why aerial application was banned in general back in the 1980s, is because of non-target exposure. So this is exposure to sort of bystanders, so people walking on footpaths, for example, and the operator, essentially. Personally, we don't see that changing, or as Syngenta, we don't see that changing very rapidly. Yes, we know that regulators are interested in this technology, but it's going to be, again, for very specialist use cases. We don't see drones in the near future being used to spray broadacre crops. It's going to be these very special use cases, steep vineyards, for example, spraying bracken control in the UK on moorlands, and then these very specialist amenity sector uses where, of course, they show a benefit. Moving into an area, though, that we can consider to be a precise application technique, band application. Now, it must be said, band application is not a new technology. I'm sure many of you on this call have seen it. You may have even used it. This type of technology delivers anywhere from 40 to 60% reduction in product usage, and is entirely dependent really on the spray band width. So that's the width that you're spraying in the field over the row. It works best in row crops for obvious reasons, where you've got space between the crops and you can either target spraying on the row or off the row. And there is actually quite a wide adoption by a lot of the specialist growers, the specialist vegetable growers, that they're using this primarily driven because of the rate reductions that are offered, but also because it allows you to target, again, that between the row or on the row. There's quite a few manufacturers, and we've got some great manufacturers here in the UK, the Micron Group and Garford, two of the big players that produce good quality band sprayers. And both systems have this option of being able to apply on the row. So, for example, maybe spraying an insecticide or a fungicide onto the crop, and then into row, you could spray a herbicide. And so their equipment has two tanks on it, one you can put for your on the row application and one you can put for your inter row application. There is also camera guidance available, so you get cameras that follow the rows, and so it's on a sort of side shifting frame, and they can follow the contours of the land, the rows, to ensure that the application is always accurate. In terms of, I guess, one of the biggest challenges for band spraying, and perhaps why it's not more widely adopted, because I think there's other use cases, sort of things like weed control in oilseed rape, maybe in maize control down in the southwest for weed control, things like that. So more broad acre crops. One of the reasons it's not widely adopted by those types of growers is because of the work rates. You can't really go more than 4 to 8 kilometers per hour. I mean, 8 kilometers per hour in my experience is pushing the envelope of work rate. And that's why the more specialist veg growers are using this technology where they have or where they require the labor to do this. Does it work? Yes, it does. We did some work several years ago now looking at SL567A, which is metalaxial M. So it's a fungicide that's used in carrots to control cavity spot disorder, which is a significant problem for carrot growers. And essentially, we wanted to compare the band applied SL567, so only putting it over the row, compared to an overall application, so spraying the whole field. So with band application, we are sort of reducing the rates by up to 40%, so saving 40% of the product. It's worth noting that a lot of carrot growers are already doing this. And essentially what you can see there is we got equivalent control from band application compared to the overall application. So it worked. So why wouldn't you do it? We dug a lot of carrots in that trial. I think lifted nearly 40,000 carrots to get this data. So, but it was really nice to see that the technique works and brings confidence to the carrot growers that are using this as a technique. We also tried it in cereal crops, specifically hybrid barley. So could we widen the rows of hybrid barley and then run an inter-row sprayer with a herbicide up the rows? And we did it with two different products when we sprayed inter-row. The first one was Reglone. Unfortunately, obviously now Reglone's been lost, but we did this prior to Reglone being lost. And you can see quite clearly that it worked quite well, because there was actually a blocked nozzle in the trial, and you can see between the rows there's plenty of black grass, and the other rows are quite clean, so it worked quite nicely. We also tried it with touchdown quattro, so glyphosate, and you can see that actually didn't have the level of accuracy from the band spray, and we ended up with a very thin crop of hybrid barley, because we managed to kill quite a lot of it. The nice thing, the beauty of Reglone is that actually you get sort of, because it's a contact acting herbicide, you might get a bit of scorch, but the crop can often grow through. So it potentially has some use cases in broadacre crops as well. So that's band application. Moving on to prescription application. So I think quite a few of you will be familiar with this as a technique, because like I mentioned at the start, great for use with fertilizer or seeds, and it's been around for a number of years, and we're starting to explore use cases in crop protection products, or the application of crop protection products. And it's really quite a simple flow. Essentially, if you've got an agronomic challenge in your field, so maybe it's patchy establishment of oilseed rape, maybe it's patches of weeds in your field, we detect the problem and use some imagery algorithms or some developed algorithms to identify different parts of the field where the problem is, and we can do that either via satellite or by drone. We can then create a prescription map, which then gets uploaded into your sprayer, and then you go out and apply to the field. So it's supposedly should be quite simple, but there are some significant challenges. The first part is in detecting the pest, weed, or disease. This is incredibly challenging to mimic the human eye, as it were, to go, oh, there's a blackgrass, or there's a wild oat, or there's some septoria. It's incredibly challenging, but there's lots of effort going into this area to develop these algorithms to be able to do this more accurate. The other challenge, I think probably all of you might have come across this, is actually uploading the map into your sprayer. Tends to be very difficult. I've spent several hours in sprayer cabs trying to put maps into boxes. It always is a significant challenge. And then finally, there's the application granularity, and this is often dictated by what section width you have on your sprayer. So if you only have say you've got a 24-meter sprayer and you only have two sections, so a 12-meter section, a 12-meter section, your application resolution is going to be 12 meters. Whereas if you've got 3-meter sections, your application resolution is less. We've been tinkering, or should we say having a go at looking at some specific use cases, and one of the areas we see this as being quite interesting is for the application of fungicides and oilseed and PGRs in oilseed rape, where we've got these sort of poorly established or patchy established crops. And we did a trial with some guys down in Kent last year. So Stuart Woods, the sprayer operator, former for City winner, helped us to test this theory. So here you can see one of Stuart's fields of oilseed rape. I think he would be quite happy to admit it was fairly patchy establishment. Cabbage stem flea beetle didn't help. We scanned the field with a drone, but we also used satellite imagery as well, just to compare the granularity of resolution. We then created a prescription map for the PGR, and then also for the fungicide. And then we create, you can see here, this is the as applied map. And with the PGR, we actually only applied to 15% of the field, and with the fungicide, we applied to 68% of the field. So you can see there's some quite significant savings that can be had via the use of prescription application. Just to touch on some of the challenges, the limitations, and potentially the future improvements. One of the biggest limitations, like I was talking about, is the boom size. If you only have 12-meter sections or 5-meter sections, your granularity is going to be limited. Spray quality. So if you're using pressure to alter your rate, so you're turning your pressure up and down, that's going to alter your droplet size produced by the nozzle. That could impact efficacy. And then this thing called a turn down ratio. So this is essentially what can you vary your rate by from a conventional hydraulic nozzle, and that's really only 30% in terms of your rate fluctuations by using just a conventional hydraulic nozzle. And then obviously you're changing your water volume if you change your pressure, which could affect through inconsistent coverage and affect control. So there are some improvements in pulse width modulation, and as you'll see from the video that's being played now, Stuart in the trial has a abatement equipped with a capstan PWM system, and this gives essentially individual nozzle rate control. So that becomes a lot more interesting, because it gives you sort of infinite turn down ratio, so you can vary your rates much more significantly from essentially 0 to 100% rate control. You've got a consistent droplet size. So that's really exciting. The other issue that is challenging with prescription application is often we're applying more than one product in the tank. So you might be applying a herbicide, fungicide, and PGR. And obviously you might not want to vary your fungicide, and you might only want to apply herbicides to certain areas. So direct injection, which again has been talked about since the 1980s, and there's several sprayers that had this fitted, is going to be incredibly important for prescription application. In fact, when we come on to talk about optical spot spraying later, it's also very important there. That will also enable you to keep your water volume consistent as well. So what about the holy grail, as it were, optical spot spraying? Real-time spraying on demand. So there's lots and lots of companies or startup companies that are developing this solution. Weedit, Carbon B, Bilberry, Eco Robotics, all these companies are developing optical spot spraying systems. And essentially there's a really nice video that Carbon B have shared with us, and you'll see that now playing, where it demonstrates what optical spot spraying is. And essentially what it's doing is it's detecting in real time the pest, weed or disease across the field via sensors, via cameras, essentially RGB cameras, near infrared cameras, and it's feeding that information back to the computer, and then it's in real time making the sprayer turn on and off individual nozzles to spray where that weed, disease or pest may be. It's very, very popular. This technology is actually being quite well adopted in places like Australia, and it's becoming more popular in the US, where you've got very low weed populations, sort of more dry, arid countries, because it drives absolutely huge product savings. Sort of in Australia, for example, they're looking at 90% plus chemical savings when it comes to weed control. So very, very useful. In Europe, perhaps more challenging, because we tend to have this more sort of carpet of weeds, a more consistent population. And obviously the limitation you've got in terms of reducing how much product you use from these systems is around the area that you're actually spraying, and also your weed population. And if you have quite a consistent weed population, if you're spraying, say, a 50 centimeter square by 50 centimeter square, which is what many of the conventional the current systems do, you can obviously see that you need to have weeds outside, more sporadically populated than in every sort of 50 centimeter square of the field. Again, interesting technology, and as it develops more and more, and the resolution of the sprayer, the granularity of the sprayer gets better, we will definitely see this emerging in Europe more widely. There's essentially two types of algorithms that these sprayers are currently using. There's a green on brown algorithm. So what this is doing is it's differentiating, it's basically identifying any green in the field, and it's spraying versus the soil. So again, very useful from a pre-plant burn down perspective. And Weedit has been around for quite a long time doing this green on brown algorithm. And then there's the green on green algorithm, which again is very complex. So this is actually detecting weeds or pests or diseases in crops. So potentially differentiating things like dock leaves in grassland to then make the spray. So those green on green algorithms are still very much in development, and that's really where the focus is now turning from these companies that are involved in this area. So a really, really exciting area of technology, and definitely something that we're going to see in the future as opportunities develop in this field. So I think to finish, there's a nice video that's capturing some of that technology that I've just talked about. Band spraying, optical spot spraying, prescription spraying. It's coming, it's exciting technology, and it's certainly really interesting. If you'd like to any more details, or if you'd like a bit more of a chat on some of these technologies, or you think there's an opportunity to do some work on any of those topics at your farm or with you, please don't hesitate to get in contact with us, because we're really exciting and looking forward to accelerating this area of technology to apply our products, control your problems in a much better way. So yeah, thank you very much.